There are two major approaches to modeling: model-based approach and data-driven approach. The model-based approach is widely used in mathematics, physics, economics, and many other areas. In the university, we always studied that the problems, for example in physics, must be resolved in the model-based manner. That we should write known physical laws, compose some algebraic or differential equations, solve them, and obtain the answer that explains how some value depends on the other values. We use laws about the nature discovered by the scientists during the centuries. And without any doubt, it's a good and preferred approach to modeling. But sometimes, especially when the object under modeling is very complex, it's rather difficult or almost impossible to construct the precise model. In this case, we can use a data-driven approach. We don't need to explicitly construct the equations and define their coefficients. We collect observations of the object or process under modeling and use the collected data to build the model. The machine learning realizes data-driven approach. It means that the machine learning models are results of the training procedure on the available data. The key features of the data-driven approach are the absence of the precise mathematical model of the object or process under modeling, the presence of the statistical input-output data, and the data processing algorithm is unknown a priori. It's a result of learning procedure. It's important to understand that the model-based approach is always more preferable than data-driven approach. The data-driven approach is worth to use only when we can't construct a precise mathematical model. This diagram shows when model-based and data-driven approaches can be used. The horizontal axis represents the complexity of the object under modeling, and the vertical axis is the amount of data available. So, if we have a simple object and we are able to construct its adequate model, the model-based approach is appropriate. Moreover, if we have data, we can also construct a data-driven model, so both models may reinforce mutually. If we deal with a complex object and we have sufficient amount of data, then the data-driven approach is appropriate. And if we have complex object and no data, then the chances to construct precise model are not so high. Continuing about the differences between mathematical statistics and machine learning, we can say that mathematical statistics is more model-based and the machine learning is more data-driven. The models of mathematical statistics are usually white box models, that we know how they work, and we can usually interpret their results. For example, linear regression, decision trees are clear and transparent mathematical models. But the machine learning models are usually black box models. We give them some input data and receive the output. And it's usually difficult to interpret what happens inside of them. The example is neural network. The difficulty of interpretation is a serious argument against machine learning models and data-driven approach in general. Nowadays, the interpretability is one of the most acute and unresolved problems in machine learning. But we can combine traditional statistics and machine learning and construct gray box models. So we can define a trade-off between interpretability and accuracy. Since the machine learning deals with data, it's also related to data science. Data science comprises many areas such as mathematics, data mining, mathematical statistics, data visualization, etc. Here is a brief history of data science. There are 5 branches: computer science, data technology, visualization, mathematics and operation research, and statistics. Since the 18th century, they developed separately. So in early computer science were Boolean algebra, Turing machines. In data technology, there are database management systems, programming languages. In statistics, there are hypothesis testing, regression models, Bayesian methods, and so on. But with the time, these branches tended to converge, and in 2000s, they have converged into a conglomerate that we call as data science.